Hey guys, hi, my name is Arpit. I work with this venture capital firm called Bloom Ventures. So, bunch of us have put together a very exciting session for you, which is to showcase some of the best of Indian hardware technology. So we have two sessions of showcase. First one is right now. The first one to go is Alpha ICs. I'll just invite Nagendra over and we'll set this up. But and there's going to be another one at 3:40. So please be back for that as well.
So everyone, I think thanks Arpit for opportunity to speak to you guys. So I just want to introduce Alpha product. Alpha is designing a next generation of AI compute, which will, I think the prior speaker has told us about the data, edge compute, and opportunity in IoT and other things. So we are addressing the same things here. So just let me introduce my team. Myself, a CEO and co-founder. So my experience is 20 years in chip design, worked in Qualcomm, NVIDIA, and other companies. And my co-founder is Mr. Vinod Dam, who is also known as father of Pentium. And other co-founder is Prashant Trivedi, who is my buddy from last 20 years. We started our career together. So apart from this, we have around 30 plus strong team in India. So most of them are PhDs and masters, mostly from ISC. So our mission is actually, to design a processor that is so unique that solves three problems: power, total cost of ownership, and data. Our novel architecture is based on agents. It's an agent-based compute. It's a unique compute in the world. We have done this compute from the scratch. It's not pivoted from, it's a general-purpose CPU to AI. This is built for AI. So in a simpler term, this explains what we are doing, a very simple term. So we talked about data. So there are umpteen number of processing technology which will support current one, where we require exponential amount of data, and sometimes it's infeasible to learn because of lack of data. So that's a bigger problem. So what Alpha has solved is this: the amount of data we require to learn continuously will saturate. For a given amount of data, we can actually learn more, learn better, and that's the reason we are more efficient than compared to any other processor. So this is some benchmark what we have compared to our peers. We are 10x better in normal computing, that is normal inference and other things, and we are the only company in the world we can do all kind of AI. So it can be a deep learning, reinforcement learning, or many other things which can be combined, hybrid systems. So this is why we are better. So we have different process technology, and we are agent-based compute. If you look at what we can learn, there is a data-centric compute and there is agent-based compute. So what we can learn from agent-based compute is much higher because our compute element is very, very high dimensional one. So if you look at CPU, it's a scalar. GPU is a vector, TPU is a tensor. So tensor is a group of vector and vector is a group of scalar. And we are much better than tensor because it's a group of tensor. It's just like it can be thousands of tensors. One agent is thousands of tensors. Another thing what we are doing is we're combining perception and decision making. What we have on the left hand side is what everybody uses for data, right? Data processing and supervised learning. But some of the applications now we are, to explore the dark data or the data which is not labeled, unstructured data, requires to do a lot of decision making. So, and that's where our processor is good at. And some of the applications is self-driving cars and robotics, and which requires learning at the edge. And this is architecture what we have on the processor. So these are our application area where we are targeting. We are targeting three markets. One is autonomous system, edge, and the core. So focus initially will be on the edge. We are actually bringing this. This product will be out next month, and this is called Alpha Edge, and this is for robotics. We are hitting around 30 teraops of DL operation. It can do edge learning. It can do parallel network processing. It can do around 5-6 network in parallel. And this is Alpha Drive, so which is meant for automotives, which has around 8 cores on that, and it can give around 240 trillion operations per second. That's how powerful it is. And this is for the data center inference. And we are actually, if you look at all the startups, we have the best numbers there for the inference. And this is analytics card what we'll be releasing next year, which is meant for what I said, without label, it can generate its own labels. So these are the traction what we have. We have very good traction in automotives and edge computing, and we are getting some traction in the other markets. So this is a sample video. I think I'll end with this. I'll quickly go. This is about what we have. I have one piece there. So this is getting deployed. Is based on Xilinx FPGA. We are soon having a chip getting taped out very soon. So this is how we did all the prototyping what we have. We connected to a Xeon processor, and through that, we did a lot of our prototyping. This is a setup what we have, and these are some of the videos which are. This is a simple network what we have simulated here. Oh, this is Atari, sorry. So there is no company in the world which has done both gaming as well as supervised learning on one chip. So this is like 32 games getting played on one core. Okay, this is very difficult to do because it requires a complete reinforcement learning and it requires a decision making part of it. And we have a best time in the world right now. The shortest time, that is 6 hours. Xeon is around 1 day, 10 hours to 1 day. So we are around 6 hours here. So we are very good at reinforcement learning. And other thing what we have is the supervised learning, that is classification. I have to slow down this video to present you guys. So what we have is AlexNet, basic AlexNet running the classification. We are currently obtaining around 3,000 images per second, 3,000 to 5,000 images per second. I have to slow down on FPGA. So this is the classification. So summary is we have designed a processor which will take AI and data processing for next level. Okay, thanks. Thank you.
Guys, if you have any questions for these, of course, these are available the entire day. You can have it. Next up is more in front and less infrastructure, but more in front of all of us, consumer IoT. Please welcome Nimble Labs. They're making something that can solve a problem that all of us have.
Hello. Yeah, so good evening, everyone. So I think I'm just settling my mind to what all we just heard. It was so overwhelming. My mind is still running like, kya hua? What happened? What went just above my head? So thanks, Alpha IC. My name is Raghav. Thank you, Arpit, for giving me the opportunity to present in front of all you wonderful people. My name is Raghav, and I run a company called Nimble, where we are helping you eat healthier by building robotic assistants for the kitchen. The last time I saw anybody under the age of 30 try to cook anything healthy, it was perhaps Maggi atta noodles. Cooking at home is tiresome, and we know how healthy atta noodles is. Today there is no convenient way for us to eat healthy every day with convenience and affordably. Domestic help is largely unavailable in developed cities like New York, and eating out is either unhealthy or, when it is healthy, too expensive for you to afford for a day-to-day basis. So what the generation does is the generation sticks to eating at home, but again, it is extremely inconvenient. So the question we're asking ourselves at Nimble is, how can we make this process of eating at home extremely simple for our generation so we can eat healthy on a day-to-day basis? And to solve this problem, we are combining health, push-button convenience, and personalized food to build an experience that allows you to eat at home every day. And we are doing that through Julia. And this video would tell you a bit.
Others life-changing. We call it Julia, your own personal automated cook. Julia makes it possible for you and your family to eat fresh food every day without the effort, without the hassle. All you have to do is choose a recipe, put in the necessary ingredients, tap cook, and sit back and relax while Julia does all the work and cooks a fantastic meal for you. Don't like your food tangy? That's fine too. You can customize our chef-designed recipes that serve up to 4 people, or build your own from scratch using thousands of combinations. Running out of ingredients? You can have them directly ordered through one of our grocery partners straight from the app. Equipped with the battery of sophisticated sensors, Julia ensures that each ingredient is added at the right time, in the correct quantity, and at the right temperature. So your food is cooked consistently every single time. Our innovative fresh part system keeps your herbs and spices aromatic, as if they were just picked from the farm. Julia can cook most one-pot dishes, Indian curries, stir fries, pasta dishes, covering a range of cuisines from all around the world. If you can recall the last 5 dishes you cooked on the stove, chances are that Julia can cook more than 3.
So that's what we're doing. We're building Julia. It's your own personal robotic cook. It's a device at your home that cooks most one-pot meals for you automatically, all at the touch of a button. We're also making it scalable enough for it to replace your cook stove one day, and allows for guided cooking. So when you don't feel like having a robot cook for you and feel like cooking yourself, you can just cook on Julia while it does the boring part of monitoring, ensuring that your food doesn't get burnt, and so on. I'll keep it very brief. Why now? Why is it the right time for us to for this to be happening today? Why has this not been done before? I think everyone else has already covered this more or less, but the pace of prototyping has become very fast. What used to happen in about a month earlier can now be done in just a matter of 3 days in much more reduced cost. This, what you see is an Indian innovation itself. This is ethereal machines. They'll be showcasing their presentation today. It's a CNC, it's a 3D printer which can again rapid prototype in all in 5 axes, using much more complexity. Advances in AI is the second driver of this. Again, as Alpha IC already mentioned. Lot of advances happening in IC, lot of open source algorithms, lot of open source frameworks are coming along. This is an old framework called TensorFlow, again released by Google, one of the popular ones. The third thing is embedded intelligence. That is, AI can now be processed on smaller chips. The Moore's law is allowing us to have cheaper, smaller, compact chips that can produce that can analyze much more data than it could have previously. Where are we as a team? We are a pre-launch company. We have iterations after iterations of prototypes which cook fantastic food, but we're still some time away to a commercial launch. A lot of expertise is required to build something like this. So we have a team of mechanical engineers, software engineers, embedded architects, and so on. A team of 10 currently, growing by 2 people approximately every month. And we have some pre-orders, although we haven't started selling. We are one of the few startups in the nation, one of the few dozen startups in the nation to be exempt under the Startup India program from paying taxes. We are winners of the Elevate 100, have a lot of support from the government of Karnataka. In fact, right now we are incubated at NASSCOM Center of Excellence for Internet of Things, which is an IoT lab sponsored by NASSCOM for hardware startups. So NASSCOM is doing a lot to get hardware startups out and foraying out of software, as Subhinder already mentioned. And we're also graduates of the Bosch Accelerator program. Bosch is Europe's largest appliance maker. So we feel that eating at home does not have to be as complicated as it is today. And we are ensuring that the future of eating remains at home. Thank you.
Yes, next, well, too much AI in this room. So there's one more company called Manjeera Systems, which does AI-based processors. We have Venu from Manjeera. Can you just give me 1 minute? I'll settle up. Yeah. I'll run it for you.
Okay. Actually, I'm feeling hungry now after Nimble Labs talk. And also, thanks to Nagendra for forming the basis for high-performance computing. Actually, it is second time that I'm speaking after Alpha IC's presentation, and I enjoyed last time, and I'm sure I enjoyed. even now. Okay, so I'm going to present you about a processor called Universal Multifunction Accelerator, a high-performance computing processor that beats the global majors by a huge margin in high-performance computing. And of course, a lot of things are said about AI. I will only take one example from AI, and I will not talk any more AI as you are saying, since you are already saying a lot of AI. AI is an ideal example for high-performance computing. And AI, as we know, it involves huge data and smart models on the data, but we also need ability to apply these smart models on this big data. And that is where you need hardware or high-performance computing hardware, semiconductor circuits. And current processors don't have that capability. Maybe you should go back. Yeah. I'm just making a general statement that current existing processors don't have the capability, but this is evident from the fact that there are so many companies coming out trying to solve this problem. And we at Manjeera have this Universal Multifunction Accelerator. I'll talk a little more about it, but basically it's that's central to all the products we offer. And this Universal Multifunction Accelerator, or UMA, goes beyond AI. Now, a little more into the problem of high-performance computing. Why do you need a new processor? What is the existing problem? Okay. When you talk about high-performance computing, these are the parameters you are looking at. Okay. And the desirable values are these. Performance should be high, power consumption should be low, and you should have programmability so that you can accelerate any algorithm. And then silicon area should be small so that the cost of fabrication of the chip is low. And then, if you look at the existing technologies, these are the general categories of existing technologies, and you see a lot of red areas there indicating the gaps in the existing technologies. And we at Manjeera came up with a ground-up new approach, fundamentally new approach. It has been said many times now, after seeing AI, that the standard von Neumann and Harvard architectures won't do. This is what Alpha ICs, or many of us are trying to do. So we have a fundamentally different approach based on what we call the middle stratum operations-based computing and novel architecture, now data path architecture. I will not go into those details, but essentially, with this, we are able to get what is desirable, exactly what is desirable. Of course, it's a qualitative comparison. I will show you more quantitative results for that. But at the end, what we are offering is 100x better performance per milliwatt power you consume per square millimeter area on the chip, compared to the best in the area of high performance computing available now. Some benchmark data here, and you can see that this IP can be used for simple signal processing applications, like synthetic aperture radar processing. One of our customers is using for that, and computer vision, and also to AI. Already Nagendra talked about LXNet, and you can see the performance for LXNet, 200 frames per second with this, and this is still scalable. It can be made much faster. And we'll show you one video wherein you can sort of see a typical use case of this IP.
Universal Multifunction Accelerator, UMA. The application that we will demonstrate today is Side View Camera System for a car. A side view camera provides seamless view from the back of the car to almost to the front, without the blind spots we find in conventional mirrors. A special lens, normally called fisheye lens, is needed to obtain nearly 180-degree view. However, fisheye lens causes extensive distortion of the image. There are algorithms available to perform distortion correction on images obtained using such fisheye cameras. However, these algorithms are very complex, and performing lens distortion correction using these algorithms need considerable time on normal processors. Here we demonstrate how UMA accelerates the lens distortion correction algorithms for real-time use. The demo setup consists of a Vertex 7 FPGA board on which a 3-core UMA system is programmed. The FPGA also contains a CPU. Both CPU and UMA are working at 100 MHz. First, let us run the lens distortion correction algorithm on CPU. You can see that CPU needs 10 seconds to perform this algorithm on one frame. So we have only 0.1 frames per second rate when CPU is used. This is too slow and makes side view camera unusable. Now let us run the lens distortion correction algorithms using UMA. You can see that with UMA we are able to achieve a frame rate of 21 frames per second. This is the uncorrected image from the camera. This is the corrected image. This demo shows that UMA provides 210 times speed up of lens distortion correction algorithm. Thank you for watching the video.
So, that's one example where UMA can be used to accelerate, fairly very complex algorithms, and these are all other several other examples. Now, when we, in this demo, it is mentioned that it's a 3-core EMA subsystem. And what is that? And that's what you see on the left side here. This is the deliverable to our customers. You can have multi-core EMA in the subsystem with the corresponding local memory and a microcontroller. This whole with a standard interface so that customer can integrate the subsystem into any of their solutions. Yeah. So these are our customers: iServo, Intel, NXP, and so on. And we are having a few other customers in the pipeline. And these are all, as I already mentioned, these are all the use cases of EMA. Goes well beyond AI, computer vision, and industrial automation. In smartphones, you can do all image and vision processing. And defense and space are other areas. We have tapped out a chip for Indian navigation system using our IP. And basically, we are addressing a huge market. Actually, this may be somewhat an old number. 50 billion is somewhat an old number. These are all the areas where this high-performance computing is of use. And we are a 5-year-old startup from Hyderabad, and we have sort of 20 plus engineers working in our company. Yeah. So that's all I need to mention today. So our aim is to build a processor company from India that competes with the global giants in this area, and that's what we are all working on. If you have any questions, I'll be happy to answer. Thank you.
Thank you, Venu. Thanks a lot, Venu. Guys, between you and your lunch is a company which is revolutionizing how you play sports, starting with cricket. Please welcome Straight Bat Gagan, and they will talk about how their technology is helping people train better.
And he goes after that one, and it's 6. Just using the pace of the bowler. But there was no half measures there from Tendulkar.
Well, what a hit.
Absolutely magnificent. Dowdy finishes off in style. A magnificent strike into the crowd. India lift the World Cup after 28 years. The parties start in the dressing room, and it's an Indian captain.
Oh, what a shot again. Wow. Virat Kohli is just flexing his muscles out there and showing what a class act he is with another wonderful cover drive.
So
Do you think Sachin would have really thought when Shoaib was running and he'll hit that square six, which is part of the folklore? When Dhoni was hitting that six a few seconds before, he would probably, wrote this script that 2011 World Cup will be remembered for this shot. Or when Virat makes his, exquisite cover drives, he thinks how beautiful he's looking, and then he plays them. Answer, I'm sure you know, they don't. They don't think here. They think from the body, and that's nothing but muscle memory. Our tool, Straight Bat, is a tool to help you build your muscle memory anywhere you play. Yeah. Yeah. This one is the next. Yeah. So cricket, which is the first line of business, right? If you look at it, sports and technology have been married for long, right? 92 is when Sachin got run out, third umpire, jaunty, I'm sure you all know that. Since then, the Hawkeye, the hotspots, the stump cameras, right? They've been really, really integral part of the game. And if you remember the game, back in 90s or early 80s, and now it's a huge difference in the way we understand the game. The game has changed per se completely. But if you peel the onion, just 2 levels below, right below the broadcasting arena, right, to the grassroots, the equipments have got better. The infra has got better. You see academies. I've just come from Dubai. I'm just amazed at the level of infrastructure these guys have. It's UAE, not even a test-playing nation. But the way we play the game has remained the same. Reason? Technology has not penetrated that below broadcasting to the grassroots. Why? Camera has been the only technology source. And if you look at it, they are pretty high on cost, amazingly high on value, right? The cameras-based technology, they're very, very expensive, as you know, but giving tremendous value. What we are trying to do is push this curve such that you create comparable value at a fraction of a cost and hence democratize technology in sports. What we are trying to solve are 3 problems. Feedback, to be instant. We all know in today's world, if feedback is not instantaneous, it's of diminishing value. Visual feedback, sports is cognitive, it's like art. You have to see it to learn it. The visual is very important. And actionable. I think the energy company was talking about actionable insights. And it has to be actionable. The less is more for sportsmen. You don't want to cloud his mind with a lot of data, which doesn't make sense. Yeah? These are the pillars of our technology. How does it work? So, awesome. So Shubman Gill, we all know the sensation. He played a session, right? And he played around 13 overs with this, 69 shots. What's his wagon wheel like? Where is he playing the game, playing the ball? Where is he impacting? Is he impacting from the crease, or is he going back to the back foot or front foot? What's his bat speed? And what's his bat speed at a time of impact, which tells him how stable you are. You generate maximum power when you have stability. If he's not, he needs to work on that. What's his ground shot percentage? And where is his bat coming from, which from cricketing point of view is very important. But as I said, visual is very important, right? So what we have done is completely translated what he is playing, right, in a complete 3D view. It shows the entire bat path, as he has played, the impact points, and all data around it. Why? Because he can see his game and understand where he's meeting the ball, right? We are doing this around 40 frames per second, the gentleman was talking about, and all with a small sensor, no cameras. Net, what we have done is we capture motion without cameras. Arpit, if you don't mind, can we? Yeah, awesome. Yeah, so that's what, instant feedback. Yeah, actionable goal settings. You can set your goals where you want to play. What's the 3D shots, timing efficiency, and visualization, right? How we have done it, I think one gentleman was talking about, it's very important to have insights which are actionable, insights which are useful. Since last 1.5 years, the product has gone to the players, the coaches, and so on and so forth every 3 weeks. And what you see of the product is no longer a figment of Rahul and my imagination. It is what they have told us. So what we are pretty confident about is we have built the right product. Reason being, every 3 weeks, they have gone through the iterations, and they have given us feedback what they want. Once we have opened up the imagination that you can capture motion without cameras. They see it, and the entire feedback has been captured that way, and the product has been built by that. Our roadmap is actually determined by what they need, rather than what we think they need. Yeah. So before we launch, there were around 650 players. Now post-launch, 400 players. Yeah, and yeah. Live on straight bat, just to say, the combination of visual information on the palm of your hands and great coaching made the players' improvement and much easier. This was somebody from Dubai. I just came back from yesterday. Yeah, and that's the team which is trying to make the dent in the sports world. Thank you.
All right, thanks, Gagan.